Okay, so I just showed you how to or evaluate functions. Now we have to also identify them. Okay, the big thing with a function is this. Okay, each value that I put in for x is only going to give me one answer. Okay, so for instance here, okay, here's an equation. Okay, if I put in 0 into this equation, okay, it's going to give me 2. Okay, if I put in 0 again, it's going to give me 2. If I put in 0 again, it's going to give me 2. Okay, no matter what you put in, if I keep putting in the same x value, I'm going to keep getting the same y value out. Okay, I put in 0, I get out 2. I put in 0, I get out 2. Okay, that would make it a function. So the key here is to get only one y value for each x value. So I'll show you kind of what that means. All right, now this is domain. Another name for domain is your x, range is your y. So basically what they're saying here is there was a function, and when you put 8 in, you got out 5. When you put in 13, you got out 14. When you put in 3, you got out 1. So each one of those domains or x values gives you one value. So one input, one output. So that is a function. Okay. Now on graphs, we have what's called a vertical line test to help us just do this. Now, I'll just say this though. The coordinate of this dot right here, its x value would be 0. And the x value of this one would be 0. Okay, but this would be 0, 3. This would be 0, 8, because these are on, this would be on 8 on the y-axis. This would be on 3. So basically what they're saying here is you put in 0 and you got out 3, and then you put in 0 again, but you got out 8. Okay, that wouldn't make sense for a function. Okay, now you can also just learn the vertical line test, which is basically this. If you can draw a straight line down anywhere in your graph and hit 2 points, it's not a function. Okay, think of it like one line, one dot would make it a function. So one line, one dot, one input, one output. Okay, that's the rule. One input, one x value gives you one y value. Exactly one y value. Okay, so this is not a function. All right, and we'll speed up a little bit. All right, and here's the thing. So you put in 10, got out 13. Put in 20, got out 20. And that's fine. Put in 14, got out 15. All right, and here's a trick on these. Basically, you can just look at these and go, look, did they give me one of each x value? Because that's really all you need to be looking for. Okay, and I'll show you that in a second when they give us one that's not. All right, vertical line. So I could draw a straight line, I'd only hit that one dot. I'd draw a straight line, I'd only hit that one dot. Okay, draw a straight line, I'd only hit that one dot. So this is still a function. All right. Now see here, now don't get confused with -6 and +6. Those are different x values. But here you go, hey, they gave me 14. I put 14 into an equation and I got out 10. Then I put in 14 again and got out 15. Doesn't make any sense. So that's not a function. Okay, I always say think about this like a test. You get 14 questions right and I give you 10 points. And the other person gets 14 questions right and they get 15 points. Okay, same 14 questions basically too. Okay, so that wouldn't make any sense, not a function. All right, can't put in 19 and get out 14. Put in 19 and then get out 10. Okay, you have each x value has to give you exactly one y value. So this x value of 19 gave us both 4 and 10, so that's not a function. All right. Each one of these things is pointing to exactly to one other number, okay? So this is a function. Okay. One line, one dot. See, I draw a line right here. I would hit these 2 dots, so this is not a function. Okay. 2 of these x values, -14. Put in -14, get out 2. Put in -14 again, and get out 12. That doesn't make any sense. Not a function. All right. All right, they're looking for which one is a function. If I draw the line right there, I'm going to hit those two dots, so not a function. All right, this one. Nowhere on this graph would I hit two dots with one straight line down, so this is my function. All right, perfect. This is the last thing. This is exactly what I was looking for. Okay, what it looks like here is they just draw arrows. So basically what they're saying is you put in 20 to an equation and you get out 16. Then you put in 20 again and get out 3. Okay, so again, you can always think about it like something like this. Here's your equation. Even though they're not showing it to you, that's like, hey, I put in 0 and I got out 2. Then you put in 0 again to the exact same equation and for some reason get out 5. Doesn't make any sense, okay? So that would not be a function. If you were able to put in the same number and get two things out. So if we put in 20, okay, and get out 16, and then I put in 20 again and got out 3, doesn't make any sense. That's not a function. Okay, same thing here. 0 cannot, you can't put in 0 and get out 15 and 5. All right, so you're basically just looking for something to point to each one time. And it wouldn't even matter if they were all the same number, okay? That's the other thing that throws people off. This could all be 5. All of these could be 5. If I put in 13 and get out 5, and then I put in 14 and get out 5, then I get 10, get out 5. Put in 17, get out 5. Each one of these x values is giving me one other number. Now, they're all the same number, but we're still okay with that. Okay? So, good luck. One input, one output. One domain, one range. Okay? Where these go. One line, one dot. Those all make our functions. Okay?